Even enormous ships can remain steady in adverse weather conditions thanks to modern technologies. Also, certain ships designed by engineers may even right themselves when flipped by waves. Here is the technology that makes ships unsinkable. We frequently see enormous ships, such as cargo ships weighing hundreds of thousands of tons, remain stable even when impacted by large waves. When a ship travels on the sea, it is subjected to various forces and pressures from the waves and wind. To survive, all ships created include a ship stability system, the ship's floating balance. So, even if the ship is tossed by waves or wind, it can stand erect again. Welcome back to another exciting video. Today's video is about how monster waves can't sink large ships in terrifying storms. Before we start the video, please like, subscribe, and press the bell icon. Stability devices. Bilge keels are one of the devices used to ensure ship stability. Bilge keels feature a wing or fin-like design that is immovable and fixed on the side of the ship's hull. The bilge keels reach around 2/3 of the ship's length, and their stability effect grows as the ship sails faster. Another stability device is the anti-rolling tank, which is a tank that is positioned across the breadth of the ship and acts to stabilize the ship's position when it tilts to the left or right. When the ship tilts to the right or left, water in the tank flows, considerably lowering the ship's rolling motion. Active and passive anti-rolling tanks are available in a moving tank. The water flow system in both tanks is more complicated and employs a pump. The active fin stabilizer, structured like a fin and dampens the ship's rolling or tilting motion, is the next type of stability device. When the ship is rolling or tilting, the ship's sensitive gyro system sends a signal to the activation system in the form of electro-hydraulics. However, active fins are ineffective when the ship travels less than 10 knots or around 18 kilometers per hour. Anti-heeling system. On container ships, there is an anti-heeling system, a servo control system used to keep the ship horizontal throughout port loading and unloading. Anti-heeling cannot be utilized as a stabilizing device on wide seas and can only be employed when the ship is in port loading and unloading containers. The anti-heeling system detects the ship's inclination angle and automatically balances the ship by pumping water into the ballast tank from right to left or vice versa. The anti-heeling system comprises a primary control panel, a pump start panel, and an anti-heeling pump, and its operation may be done automatically and manually. Furthermore, a ship's stability system is controlled by its balance points, which define the amount of the ship's stability. As a result, the crew must always evaluate the ship's balancing points. One of the leading causes of accidents is failing to account for the ship's stability calculations, whether the ship is at sea or in port. Self-righting boats. As a result, rescue ships are used for search and rescue operations, offering help to victims of maritime accidents at sea. However, during these rescue efforts, strong weather conditions and large sea waves might impede SAR operations and cause the ship to capsize. To overcome this issue, engineers worldwide have created rescue ships based on self-righting boats, which can return to their previous position even after being rotated 180 degrees. Self-righting boats can attain rapid speeds and resist various extreme sea conditions, in addition to being able to right themselves. Many firms make these self-righting boats, including the Royal National Lifeboat Institution, RNLI, in the United Kingdom. Numerous critical components in developing self-righting boats allow them to flip back on their own. The first part is the ship's original design, in which all heavy equipment and things must be positioned as low as feasible within the ship. The second component is the crew's operating and control space, which must be lightweight, robust, and air-filled. Furthermore, the crew access door must be watertight to prevent water from entering the area if the ship capsizes. A pendulum system is also used on self-righting boats to keep water from entering the ship's interior. When the self-righting boat capsizes, the weights in the pendulum system hang vertically, causing all open portions to close and prevent water from entering the ship. These self-righting boats also have an inbuilt technology that detects capsize. This device automatically safeguards the boat by turning off the radar and engines before righting the boat back to its original place. When the boat returns to its normal location, the radar and engines are restarted. Additionally, crew personnel inside the boat must be seated and restrained with safety belts to safeguard their safety during capsizing. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.